Hello everyone, welcome to our channel. And in this video, we are going to learn about Newton's first law of motion. So let's get started. What is Newton's first law of motion? According to Newton's first law of motion, if there is no force acting on an object, then the object will continue to be in the state of rest, or it will continue to be in the state of uniform motion along a straight path. That means the object will remain at rest or in motion with constant velocity along a straight path unless an external unbalanced force acts on it. In simple words, we can say that Newton's first law of motion states that a body remains in the state of rest or uniform motion in a straight line unless and until an external force acts on it. Putting Newton's first law of motion in simple words, a body will not start moving until and unless an external force acts on it. Once it is set in motion, it will not stop or change its velocity until and unless some force acts upon it once more. The first law of motion is sometimes also known as the law of inertia. Inertia is defined as the property of matter by virtue of which it continues to be at rest or in motion with uniform speed in a straight line unless compelled by an external force to change its state of rest or motion. This means when no force is applied on the object, it will continue to be in the state of rest or uniform motion along a straight path. But when an unbalanced force is applied on the object, it will change the state of rest or motion of the object. For example, when we apply a force on a stationary object, it will start moving from the state of rest. If a moving object is not acted upon by any force, it will continue to move with uniform velocity. On the other hand, if a force is applied on the moving object, then it will change the velocity of the object. Let's take an example to understand Newton's first law of motion. Let's consider a hockey ball which is at rest. If we apply a force on the hockey ball, it will start rolling on the table. Once the hockey ball starts rolling on the table with constant velocity, it will continue to roll on the table with the same velocity and in the same direction until some force opposes its motion. In this case, the frictional force opposes the motion of the ball and brings the ball to rest. As we know, friction is an example of a force. Here, the force applied by us on the ball changes the state of rest of the ball. Hence, the ball moves from the state of rest to the state of motion. And when the frictional force is applied on the ball, it changes the state of motion of the ball from uniform motion to rest. Thus, according to Newton's first law of motion, a body at rest will remain at rest and a body in motion will remain in motion with uniform velocity in a straight line unless and until an external force acts on it. There are two conditions on which the first law of motion is dependent. Objects at rest. When an object is at rest, velocity and acceleration are zero. Therefore, the object continues to be at rest. Objects in motion. When an object is in motion, velocity is not equal to zero, while acceleration is equal to zero. Therefore, the object will continue to be in motion with constant velocity and in the same direction. We know from the second law of motion that the acceleration produced in a body is directly proportional to the force applied on it and inversely proportional to the mass of the body. Mathematically, F equals ma, where m is the mass of the body and a is the acceleration produced in the body. If the mass of the body is very large, then a very large force is required to produce unit acceleration in the body. Therefore, a body with a large mass does not easily change its state of rest or motion. Now let's take the example of planets revolving around the Sun. We know that all the planets are revolving around the Sun in a fixed orbit. This is only possible because the gravitational force of attraction between the planets and the Sun balances each other. If the gravitational force of attraction between the Sun and the planets is unbalanced, then either the planet will go in an elliptical orbit or the planet will fall into the Sun. So now we have learned that Newton's first law of motion states that a body at rest will remain at rest, and a body in motion will remain in motion with constant velocity in a straight line unless and until an external force acts on it. Also, we learned that Newton's first law of motion is dependent on two conditions: objects at rest and objects in motion. Now let's take some questions from the previous examples. Question 1. A car is moving with a constant velocity. Is a force required to keep the car moving with constant velocity? According to Newton's first law of motion, we do not require any force to keep the car in motion with constant velocity. In this case, the frictional force and the force applied by the engine are balanced. Therefore, the car will continue to be in the state of uniform motion. Question 2. When a train starts moving from a station, passengers in the train start falling forward. Why, when the train starts moving, the force applied by the track on the wheels makes the train move forward. At the same time, the force is also applied on the passengers and the train. Due to inertia, the passengers want to remain at rest with respect to the ground. As a result, the passengers start falling forward. Question 3. Why is it difficult to move a large box than a small box of the same height when they are at rest? As we know, a body at rest will remain at rest unless and until an external force acts on it. The heavier the body, the more will be its mass, and the more force is required to move the body from the state of rest to the state of motion. Question 4. What happens to the velocity of an object when a force acts on it? When a force acts on an object, it changes the state of rest or motion of the object. As a result, the velocity of the object changes. Question 5. How inertia is related to the mass of the body? Inertia is the property of matter by virtue of which it continues to be in the state of rest or in motion with uniform speed in a straight line unless compelled by an external force to change its state of rest or motion. We know that a body with a larger mass has more inertia. It means the more massive the body, the more will be its inertia. So this was all about Newton's first law of motion. I hope you enjoyed this video. If so, do hit the like button and do share this video with your loved ones. And do tell me in the comments section what you like most about this video. I'll see you guys in the next video. Till then, peace out.